Hi guys, and welcome to the debrief for exercise 2B. Generally, my comments for this assignment is that it is quite well done except for a few minor errors. So just take note when you substitute in future, carefully substitute. And apart from that, I think question 13 wasn't very well done. So let's go straight to it. This is what question 13 says. Show that the equation 2x squared plus 5hx equals to 3k has real and distinct roots for all positive values of k. Okay, this question cannot be attempted like your other questions because this question involves proving because of this word show. So you need to show that this equation has real and distinct roots, which means that you need to show that b squared minus 4ac is more than 0, given that k is positive for all positive values of k. Okay, this is very unlike your other questions, which always tells you, okay, if this equation has a certain kind of roots, find the range of values of k. Okay, this is very different from such questions because right now the question wants you to show that b squared minus 4ac is more than 0, which is why you cannot use b squared minus 4ac more than 0, which is what some of you did. You use b squared minus 4ac more than 0 to find the range of values of k. You cannot do that because this is what we need to show. You cannot use this. Okay? And also, apart from that, it is also not correct as the question did not ask you to find the range of values of k. Okay, the question wants you to prove that b squared minus 4ac is more than 0. Okay, I read one more time. The question wants you to prove that b squared minus 4ac is more than 0, which means that you need to show this inequality of b squared minus 4ac. So if we cannot use b squared minus 4ac more than 0, how do we go about showing that b squared minus 4ac is more than 0? Okay, you realize that some of the steps are actually quite similar, but also not that similar. Okay, so let's go straight into the solution. How do we go about showing? Okay, first thing, rearrange the equation to our quadratic form. Okay, so you can see this is the final quadratic form. Okay, step 2, evaluate b squared minus 4ac. Okay, I use the word evaluate here because we do not form the inequality of b squared minus 4ac here, unlike your other exercises. We evaluate b squared minus 4ac. So let's evaluate this in terms of h and k first. Okay, so we get b squared minus 4ac equals to 5h squared minus 4 times 2 times minus 3k, and we get this as the term for b squared minus 4ac. So, like I said, our goal here is to show that b squared minus 4ac is more than 0. So in the same way, our goal is to show that this particular term here, 25h squared plus 24k, is more than 0. We want to show this. So how do we go about showing this? Okay, so step 3, show that b squared minus 4ac is more than 0 by using the given conditions. Okay, so let's use the given conditions. Okay, since 25h squared is positive for all real values of h. Now, let's go back to our term. Okay, this is our term for b squared minus 4ac, right? 25h squared here will always be positive or more than or equals to 0. Correct? Because we talked about all squared terms. Any number, any positive number times anything's squared will always give you something positive, right? Because all squared numbers are always positive. Okay, and 24k, which is the second term, is more than 0 for all positive values of k, which is what the question gave me. The question told me that k is positive, so 24k is always positive for all values of k. 25h squared plus 24k will be more than 0. So by using this, we have successfully proven that b squared minus 4ac, or which is this term 25h squared plus 24k, is actually more than 0, and therefore we can conclude that this equation has two real and distinct roots. Alright, so to quickly recap, when you get show questions, show that this equation has a certain kind of roots, okay, you want to rearrange your equation to quadratic form, step 1. Step 2, evaluate, okay, evaluate what b squared minus 4ac is, okay, and then use the certain conditions that are given to show your inequality on b squared minus 4ac, okay. Okay, this is actually quite similar to one of the examples that I've gone through in class. So if you find yourself forgetting or not being able to follow what this video was talking about, you might want to go back to this question to refresh your memory. Alright, so take care and all the best.